All right, I would like to thank Metropolitan Community College for giving me access to this wonderful document. The link to the document is up here at the top. It is a great resource for all sorts of review of factoring. So I'm going to go through it for my students and anyone else who wants to watch. So greatest common factor is something we want to look for before we factor any problem. So what is the greatest common factor? A factor that two numbers have in common. So here we've done a prime factorization. We've broken down 18 and said, oh, 18 is 9 times 2 and 9 is 3 times 3. So 3, 3, and 2 are, if we multiply 3 times 3 times 2, we'll get back to 18. So then we're looking at, okay, well, what do these two numbers have in common? Well, they have a 2 factor and a 3 factor, so the greatest common factor is 6. All right. There is a feature on the TI calculator that you can do. So here, like 28 and 49, if I break down 28, I get 4 times 7. I could break that down more and go 2 times 2, but I also already see this 49 is 7 times 7. So I don't feel like I need to break that down anymore. The only common factor I see is a 7. Okay, so I can say that the GCF is 7. Now the TI calculator has a feature on it called GCD. The GCD is a command that returns the greatest common divisor of two non-negative integers. So it does have some restrictions. It can't be negative integers. So if you were to do that same problem we just did, if you go to math, go right to numbers. Right here, number 9 is GCD. So the greatest common divisor of 28, you put a comma between, and 49 is 7. All right, so it can help if you're dealing with some really large numbers that you don't want to do the whole prime factorization of. All right, so let's look down here. So here we're taking out what is the greatest common factor. We want to factor that out. So I feel like students are very comfortable with the distributive property where they take a term and multiply it in to a binomial. So a monomial times a binomial, they distribute that term. So really what factoring is the reverse of that. So we're saying, what do these have in common? Let's factor it out. So we're pulling out what those two terms have in common. So we're rewriting it as a product of two things. Okay, so here, 6x plus 3, 6x plus 3, what I want my students to do is break down and say, okay, 6 is 2 times 3 times x, so 6x, 2 times 3 times x, plus 3. And then think about what do they have in common? Well, they both have a 3 factor. So that's what I'm going to factor out. And once I factor that 3 out, really this is 3 times 1, right? Here, what's left is 2x plus 1. So before we say we're done, we want to double check. If I multiply this back in, 2 times 3, 2x times 3 is 6x. Okay, that checks out. And 3 times 1 is 3. It's really important to check your work before you say that that's your answer. All right, let's try another one. So 24, if we break it down to prime factorization, 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So if I break 24 down into its prime factorization, 2 times 2 times 2 times 3 will give me 24. I've got x and x. 8 is 2 times 2 times 2. Now, maybe it's not necessary to break down all the way to the prime factors if you see, oh yeah, they have an 8 in common. So you could just say, oh yeah, 8 times 3 and 8. So here they both have an 8 factor, or 3 2 factors. They also have an x factor. So you can factor out an 8x, and what remains when you're done is whatever's left over. So we have a 3x minus, and here if nothing's left over, it's just a 1. So let's multiply this back in and make sure we got it. 8 times 3 is 24, x squared, good, minus 8x. So that would be factoring out that GCF. Okay, so here are a bunch of practice problems. The answer key is the very last, at the very end of this video. So if you want to practice a couple and then check your answer, that'd be great. There also are 3 terms. So over here, let's try this. So 13, 13 times 2, 13 times 3. So I see some 13s in there. So here I have 13m plus 13 times 2 times m minus, oh, running out of space here, minus 13 times 3 times m times m times m. Okay, so if we go and say, all right, well, I have 13m here, 13m here, 13m there. Is there anything else they all have? Nope. Okay, so I'm going to take out the 13m. This was 13m times 1 plus 2m minus 3m squared. So this actually may be factorable, and we'll talk about factoring that in just a minute. All right, but here we're focusing on just what is the greatest common factor, what do they all have in common, and factor that out. All right. A difference of 2 squares. These are so much fun once you get them. So the formula here is if you have a squared minus b squared, if you have something that's a difference of 2 perfect squares, you end up with the factors a plus b, a minus b. So if I multiply this back together, a times a is a squared. Then when we do distributive property, b times a is ab plus ab, and here we have minus ab, and then minus b squared. So what happens is the positive ab and the negative ab, the middle terms, cancel out because they end up being the exact same thing, only opposites. So we end up with a squared minus b squared. So if we see this pattern of a perfect square minus another perfect square, we can say, oh yeah, I just take the square root of the first, and that goes first. I take the square root of the second, and that goes second. And one's plus, one's minus. All right, so following that pattern can help us. Perfect square, difference of 2 squares. X plus 3, x minus 3. Now this is a trick. Trying to trick you. It has to be a negative here, because if I put a positive to get my positive 4 or a negative, the middle terms will not cancel out. So that we would consider prime. All right. Now, then we get to more exciting looking ones like this. This is still just perfect square. 9y squared is what quantity squared? Really, 9 is 3 squared. Y squared is just y squared. So 3y, if I square 3y, 3 times 3 is 9. Y times y is y squared. That's my a value. Minus 16 squared is 4 squared. So once I found what my a and b are, then I can say, all right, a plus b, and a minus b. All right, great. So there are a bunch more for you to practice there. All right, so please try some. In this situation, I noticed there's a negative here and a positive there. So I could either switch that around, 16 minus x squared, do it that way, or I could factor out a negative 1 and say negative 1 times x squared minus 16 and factor it that way. So either way would work. All right, that is difference of 2 squares. All right, factoring perfect square trinomials. So these have a special pattern to them. It's the same really as factoring a trinomial, but there's something special about them in the sense that this, what times what, gave me 16 that added to 8. Sometimes we do this diamond puzzle where we put 16 and 8 and we say what times what has a product, what two numbers have a product of 16 and a sum of 8. Well, 4 times 4 is 16 and 4 plus 4 is 8. So they're special in the sense that x plus 4 times x plus 4, we can write it x plus 4 squared. All right, and here we have 8 times 8, 8 plus 8, but wait, I need it to be negative, so they both need to be negative. X minus 8 squared. Negative 8 times negative 8, negative 8 plus negative 8. All right, here, what times what? What plus what? 6 times 6, 6 plus 6. All right, x plus 6, quantity squared. 6 times 6 is 36, 6 plus 6 is 12. All right, so if you want to practice some of those, oh, all of a sudden this one looks different. Let's look at this one real quick. What quantity are we squaring? Here, what times what is 16y squared? 4y times 4y would give me 16y squared. Well, 4y plus 4y would give me 8y. All right. If I wasn't sure, if I didn't feel confident with that, I could check it. Some of you like the box method. 4y plus 1, where you do this, and you multiply. 4 times 4 is 16, y times y squared. 4y, so here we're multiplying 4y times 1, 4y, and 1 times 1 is 1. We add up these like terms because they have the same degree, y to the 1 power, so we get 16y squared plus 8y plus 1. We can check our answer and make sure that I really do get back to what I started with. I say always check your answer if you have any uncertainty. All right? Even if you don't, if you have time, check your work. All right, so you can practice more of those if you'd like. All right, special challenge factoring. I think I'm gonna skip these. This is like practice of a combination of all the things we just looked at, but I'm just gonna do kind of an overview of each type of factoring. All right, I'm not a huge fan of this example, but they're trying to show you that the two numbers you pick need to multiply to get 10, 5 times 2 is 10, and sum to get 7. Yeah. Okay, so I presented many different ways of working with these. We talked about the diamond puzzles, what multiplies to give 8, that adds to give 6. So 1 and 8, or 4 and 2. 1 and 8, 4 and 2 seem to work out. So we can break that down. X times x is x squared. 4 times 2 is 8. And how are we going to get positive 6? They need to both be positive. All right. So, yeah. All right. Okay. Some people like to do the reverse diamond puzzle. I'll do it for this one. So, not the diamond puzzle. The reverse box method. So here, x squared goes here. 16 goes here. And negative 10 is what I want these, negative 10x, the middle term is what I want these two boxes to add up to. So I have to ask myself, okay, what times what gave me x squared? Well, x times x. All right, and what times what gave me 16? So I have some choices, 1 and 16, 2 and 8, 4 and 4. But I need it to add up to negative 10. So 1 and 16, 2 and 8, 4 and 4. Which of those is most likely going to get me to 10? Well, I see 8 and 2 add up to 10, but I need it to be negative 10. So in order to get negative 10, both are going to be negative. So negative 2, negative 8. Does it still multiply? Check, double check. Does it still multiply to give positive 16? Yes, it does. Here I would get negative 2x. Here I get negative 8x. Add them up. Yep, we get that. So our two factors are on the outside here. X minus 2. It's important that we write them next to each other because they are being multiplied. And x minus 8. So that would be the answer to this problem here. I'm sorry, it would be the factored version of it. All right, so here we have our standard form, and here we have our factored form. All right, great. So there's a bunch of practice on that. You guys got this in class. If you haven't already gotten it, you've got it today in class, or you will get it today in class. All right. Oh, all right. So factoring when a is greater than 1. So here we have ax squared plus bx plus c, and our a value isn't just a 1 anymore. Now we have a larger number, like 2 or 7 or 5. Those are nice, they're prime numbers. Once we get to more complex numbers, maybe it gets a little more exciting. All right, but so there are lots of different methods. There's the AC method, which is taught. AC method. There is something called the lazy AC method. We call Mr. Choi is a teacher at our school, and we call a guess and check method the Mr. Choi method. There's reverse box method, slide and divide. So all the different choices maybe make this a little more difficult because not everybody clicks with a different method. So I will show you a couple methods here. All right, so let's start with the first one. We're going to do AC method. So we're going to multiply our A and our C. So A times C would be -6, and B goes here, -5. So we need to find two values that multiply to get -6, add to get -5. So 6 and 5 are always tricky because it's, well, 1 and 6 and 2 and 3, right? 1 and 6, 2 and 3, I could get 5 either way. So we have to think about, all right, well, if 6 is negative, only one of these is allowed to be negative. And here, to get -5, I would need both negative, so that one's not going to work. So I need a -5. I need to have a -6 and a +1. So it looks like 1 and -6 would add up to -5. This one won't work. All right. So what we do with those numbers is we break down our middle terms. So we have 2x squared minus 5x minus 3. But instead of -5x, we're going to break it down to 1x and -6x. We're going to bring down -3 and bring down 2x squared. Now we do something called factor by grouping. We say, what's the GCF here? We were just talking about that a minute ago. -3 is the common factor in both of those. So what's left over when I factor out a -3? A 2 factor and an x factor. If I multiply that back together, I would get that. All right, so we have 2x minus, plus 1. Sorry, because if I multiply that back in, I'd get -3. All right, here what do I have in common? It looks like only an x. So I take out the x factor in common, and 2x plus 1 is left over. This and this should be identical. So the two factors are 2x plus 1. That's one of my factors. The other factor is right here, x minus 3. So this is probably the most common method. I've heard it called the British method, but the AC method. All right. So I'm going to show you that same exact problem, but then in another method. Well, let's do lazy AC. Okay. So lazy AC starts the same way, but I'm going to say something that's untrue right here for just a second. I'm going to put 2x. I'm going to put 2x. And I'm going to put the 1. I'm going to put the -6. Now this, I can't say it's equal. It's not equal. I'm doing this a lazy way. But I put in an extra 2 here. So I want to see which of these has a GCF. Which of these has something in common? Well, this one right here has a 2 factor in common. So I'm going to factor out that 2 and get x minus 3. There are my factors. Wow. So that was the lazy AC method. So it was a little quicker by just looking at, here, let me put an extra 2 in and then simplify that 2 out. Okay? All right. So the slide and divide and the Mr. Choi. Okay, so let's do 3x squared plus 10x minus 8 and do slide and divide. Do you want to do it? Here. You do it on your desk. Try Okay, so slide and divide says you take the 3, multiply it times -8. And we're going to make this problem into a problem where a is equal to 1. X squared plus 10x. So we take away the 3. 3 times 8, -24. All right. So we took that 3, we moved it over here, we made it there. Now, I cannot write equals here because these are not equal. All right, this is just a middle step to help me find some stuff I need. Okay, so x times x. Now I want to say, what times what is 24 that adds to 10? 1 and 24. 2 and 12. 3 and 8. 4 and 6. So I need to find which of those will get me to 10, and I see 2 that could. So 10 and 12, I could get to 10, but 4 and 6, I could also get to 10. Now here, both would have to be positive to get me to positive 10, but that won't work because I have a negative. All right, so here, I need 1 to be positive and 1 to be negative. In this case, I'll end up with a positive 10 and a negative 24. Okay, so I put in my numbers, -2 and positive 12. So the slide and divide, here we did the slide. Now this is not equal to that, right? So you have to be careful not to think that we're done. So if I slid that 3 over, I now have to divide by 3 and divide by 3. I need to simplify that fraction. If it doesn't simplify, then whatever's here needs to go back. Whatever's here needs to go back there. So 3x, sorry, that's hard to see. 3x minus 2 would be my first factor. And here, 12 divided by 3 simplifies, and we get x plus 4. So that, now we can say this and this are equal. If I multiply this back together, 3x squared is good. Plus 12 minus 2, positive 10, minus 8. Works out. Okay, so that's called the slide and divide method. All right, I saved my favorite method for last, the Mr. Choi method. I'm going to do it up here. We don't need much space. 3x squared plus 10x minus 8. So Mr. Choi's method, let me put a line here, is really just a guess and check method. We're putting below 3x squared. What times what is 3x squared? Well, 3x times x is 3x squared. And what times what is 8? Well, I could go with 1 and 8 or 2 and 4. I always go with the middle one first, so 2 and 4. All right, so I'm just guessing. I could have put the 4 there and the 2 there. I'm not sure which one is going to work. All right, so I do a crisscross multiply. And really what that is it's checking the inners and the outers. So 3x times 4 is 12x, and x times 2 is 2x. And I want them to add up to 10. Can I get a positive 10x? Can I get this to be negative? So 1 has to be negative. So I would need this negative and this positive. Okay, so a -2, how did I get the -2? Right here. So I'm going to put a negative there and a positive there. So my factors are straight across 3x minus 2 and x plus 4. Again, that's hard to see. Okay, 3x, minus 2 and x plus 4. So we get the same answer that we got down here. All right, now I was lucky and I got it on the first try. If it hadn't worked on the first try, if I had tried 4 here and 2 there, I would have gotten 4 and 6. Ooh, 4 and 6 looks like it's going to work, but it wouldn't have worked out because of the negatives. All right. So those are a bunch of different ways to factor. You really got to find which way you like and practice that. All right, hopefully this video was of some help. Please, please, please practice some. The answer key, I will jump to the answer key. Answer key is here. I'm going to zoom in, go slowly over it so you can check your answers as you're practicing. On my website, I'll also put a link to the document if you didn't get one. Difference of two squares. You'll need to hit pause because I'm just going to move through this. Perfect square trinomials. Alright, I kind of skipped over the special factoring challenge, but there was a mixture of different types in there. Factoring trinomials. Now, if it's not factorable, sometimes it's not possible. We write prime. Means it's only one in itself can factor. Alright, other page. This is a greater than 1. Alright, so that should probably get you through what you need. Putting it all together, factoring out GCF first, and then factoring. Alright, and then the last factor by grouping, we kind of looked at that in the AC method, where we factor out GCF of the first two terms and the last two terms. Alright, thank you for watching. Hopefully it was helpful. Thanks, bye.